Today we're going to look at the hard problem in a book called Mathematical Analysis that was published roughly 53 years ago. It was published in 1970 originally. So our problem is to find the derivative of this expression. As you can see, the expression here. So throughout this question, we're going to look at several formulas to solve such a question. So first of all, our problem is quite simple. We don't need to stress ourselves on this. So first of all, if we define to solve this kind of problem, we need to know one thing, and that is if you notice, there's a constant value in the expression itself, and for constant expressions in finding derivatives, we have a formula which you can see in the first one. So if we have a constant value in our derivative, we can just extract it to the outside in order to solve it. So we don't need to just put this constant value and multiply or do certain operations within the function. So we're just gonna forget about this 1/3, and then once we forgot it, we're going to extract it to outside and deal with our original ln function and find its derivative, and then multiply by 1/3, the constant value. So now let's go to the next function, next formula, I would say. That is the formula of the second, which is the formula to find the derivative of ln x. In order to find a ln x derivative, we just need to know one single formula. It's going to be 1/x, which is the parameter of the ln formula. But most people forget about this. We need to also multiply this 1/x to the derivative of the parameter, the derivative of the value that we inversed. So if we apply this rule right here, we're going to do 1/our parameter, and then multiplied by the dx, the derivative of the original parameter. So after we've done that, we're just going to leave this behind, and then we're going to deal with the next part, which is to find the derivative of the division of these expressions. So it's a bit too long, as you can see, and there's also a special formula for this, which is the Dort formula, which states that in order to find the derivative of two functions that are dividing each other, we're just going to use this formula. So the formula of the first function times the second function minus the formula of the second function times the first function, and divided by the denominator square. So we just applied it, we're going to get this value right here, and since the denominator is too gigantic, so we're just going to move here, and we're going to make it simplified and to make our problem to go further. So if we simplify this part, we're going to get just this part, so 2x cubed minus 2. We just multiply it and then simplify it by adding and subtracting the values with the same signs. And that goes to the same here also. Then we're gonna subtract them because there's a subtraction here. We need to be careful of that. The overall product, or the overall result of this, is going to be 3x squared minus 3, as you can see. And then if we just take this value, we can just actually simplify it further. So we can just make 3 outside of the original function. So we're just going to make this like this, x squared minus 1. So it's going to be 3/x squared minus 1. And then what can we do further? Well, we can just actually simplify further by using the original formulas to find the expressions. So it's going to be 3 times x minus 1 times x plus 1 to make our function further simplified. So after the simplifications, we're just going to leave the denominator part still remain as a still remain, and then after that we're gonna multiply by this value, So if you be careful, just like the other function, just like the other function, we're just gonna do this expression more simple by making x minus 1 squared. So this is x minus 1 squared. You can just rewrite this as x minus 1 squared. That's why I typed here x minus 1 squared. And then after doing that, we're just going to cancel the x minus 1s. And then we're going to leave with 3 times x plus 1 divided by this expression. But if you don't forget, we have a constant value, which is 3 over 1. And now we need to use 3 over 1 to multiply by this function actually, to get our main results. Because in here, if you extract the constant, but you need to re-multiply by the function, the remaining function's derivative to the constant. So if we just multiply by this function by 1 over 3, this 3 will be cancelled, and we will get our main result, which is this expression. Thank you for watching. See you in the next video.